Hey guys, section 9.2 here, solving radical equations in Algebra 1. So radical equations, also real quick guys, this will go along with the IXL skills. Double F4 and double F5 is in the letter you'd put in the chat there. F. Okay, double F4 and double F5. Solving radical equations. So radical equations are equations that contain radicals with variables in the radicand. And so, like I said, equations that contain radicals with variables in the radicand are called radical equations. I like to think that's pretty straightforward. So one of the things I love about math is like, equation with radicals, radical equations. So we have 3 steps here to solve. So the first is to isolate the radical on one side of the equation. Isolate means to get by itself, okay? We've done that before where we've isolated the variable. Here we're isolating the radical, okay? So our first step is to isolate, and I'm going to even underline the radical. Next thing is to square both sides to eliminate the radical, and then we check to make sure the solutions work. Now this is actually even more important than before to check that the solutions work, because sometimes squaring both sides will produce what we call an extraneous solution. And this is an answer that does not work in the original equation. So you need to check every time just in case. And one way I like to remember what it's called is the beginning of this word extra. Okay, it shouldn't be there. It wasn't supposed to be there originally. So a little note here, a radical will be greater than or equal to 0 since we do not get a real number when we take the square root of a negative number. Okay, you can't take the square root of a negative number and get a real number because nothing times itself will become negative. Only something times itself, because it has the same sign then, whether it's both negative or both positive, will end up being positive. Continuing on right below this here, I'm doing some examples. So solve each equation and check your answer. So if we're following our steps here, step 1 is to isolate the radical on one side of the equation. Well, square root of x, the radical is already by itself. There's nothing over there. So that step is done. Step 2, square both sides to eliminate the radical. Okay, so I'm going to square both sides, just like I would multiply both sides by something or add both sides by something. Same idea, I'm going to square both sides. Now what happens is a square and a square root undo each other, okay? They are inverse operations, just like multiplying and dividing are inverse operations or adding and subtracting are. Squares and square roots undo each other, okay? And the math behind that, I'll show it real quick here off to the side, and then I'll erase it. But if you take the square root of x and you square it, that's the same thing as having the square root of x times the square root of x, because squaring something just means that there's 2 of them being multiplied together. And now we said before, square root of x and square root of x, well, any 2 of the same square roots multiplied together, you just get the normal number, okay, or the normal variable there, okay? Another way to think about it from here, if you have square root of x times square root of x, is to multiply the radicands, square root of x squared. Okay, well, and what times what is x squared? Well, that's x. So that's our explanation of, hey, why that works. But what we need to remember from this is that squaring and square roots are inverses of each other. So anytime you square a square root or square root a square, you're left with the radicand, x. And then we take 6 squared and we get 36. So we have x equals 36 as our answer. Now we're supposed to check our answer though. I'm going to go over here and check my answer. So I plug it back in, and so I say square root of x equals 36, so square root of 36 equals 6. I said square root of x equals 36, I'm going to say square root of x equals 6. We say, does the square root of 36 equal 6? Yep, it checks out. On number 2 here, we'll walk through our 3 steps again. Number 1, isolate the radical. The radical is not completely by itself because it's still being added with 2 on this side of the equation. So we need to first isolate it by subtracting 2. So we end up getting the square root of y is equal to 3. Now we move on to our next step, where we square both sides of the equation. This will get rid of the radical. So square root of y squared is going to be just normal y. And 3 squared is 9. and that is our answer. Like I said, we want to go through and we want to check our work. So I plug 9 back into my original equation. So square root of 9 instead of y plus 2 equals 5. I'm going to ask that as a question. The square root of 9 is 3. Does 3 plus 2 equal 5? Yeah, last time I checked. On to the next problem here. 2 times the square root of a equals 10. So our first step is to isolate. Oh, not isolated yet. You have to divide by 2 to get rid of the multiplication. Square root of a equals 5. Now the radical is isolated, so now we can do step 2, square both sides. Squaring a square root leaves us with a radicand. So a equals 25, ha ha ha. Want to go back and check our answer? 2 times the square root of 25 equals 10. Well, 2 times the square root of 25, 2 times 5. Does that equal 10? Yes, it does. And if this is something, guys, where you want to pause the video and work ahead of me a little bit and then check by going on with the video to see if you did it right, that'd be a great way to go through these notes. On number 4 here, 4 equals the square root of 3 minus x. Now, our first step says to isolate the radical. So we have to ask ourselves a question. Where is the radical? Well, it's this whole thing over here. So the radical is actually by itself. The variable is not by itself, but if we look very carefully at the instructions, it says the radical needs to be isolated, not the variable. So step 1's actually done already. So now we move on to step 2 where we square both sides. 4 squared is 16. And the square root of 3 minus x being squared is just 3 minus x. You're left with whatever the radicand is because the square and square root undo each other. So now we can solve this like we normally would. Subtract 3, 13 equals, don't forget it's a negative x. You have to divide by a negative 1 or multiply by a negative 1. Negative 13 is equal to x. Now we plug this back in to check to see if it actually works. 4 equals the square root of 3 minus negative 13. Well, double negatives there, so you change it to add or keep change as we often know it. 4 equals the square root of, well, 3 plus 13 is 16. Yep, 4 is the square root of 16, so it worked out. Continuing on, we have some more examples here, and I'll just keep working through all these examples for us, guys. The square root of negative r equals 7. It's already isolated, so we move on to squaring. Negative r equals 49, divided by negative 1. R equals negative 49. Plug it back in like good math students. And we say, okay, well, we have a square root of negative 49 equals 7, or equals. Negative and negative, positive. So the square root of positive 49, yep, that's 7. 7 does equal 7. Checks out. Let's try number 6 here. So the square root of 3t squared equals 6. Radical is isolated, nothing else with it on this side, because everything's underneath the radical. So we move on to squaring both sides. And we end up getting 3t squared is equal to 36. Continuing on, we have to divide by 3. T squared equals 12. Ooh, we know before from the square root method that we can square root both sides to get rid of that square. T is equal to positive or negative square root of 12. Ooh, we're going to need to make ourselves some more room here. So I'm going to move it up here for me. T is equal to positive negative square root of 12. Just rewrite that because I still can simplify that into T is equal to positive or negative square root of 4 times square root of 3, which is T equals the positive or negative 2 times the square root of 3. Okay? Now, I end up with two different answers here. So you might be asking yourselves the question, do we have to check both? Well, let's just first look at what happens if we check them. Okay? Let's analyze this a bit. So if I start to check, and I plug in 3t squared, so I plug in 3 times 2 times square root of 3, the positive version, and I square that. So under a radical. Okay? And it's equal to 6. Well, 2 times the square root of 3 being squared, we can distribute that 2 to the 2 into the square root of 3. And so you'd really have the square root of 3 times 4 times 3 equals 6. Well, 3 times 4 times 3, 3 times 4 is 12, times 3 is 36. Square root of 36 does, in fact, equal 6. And if we were to check the other side of things, I'm going to make a mess here for a moment. If we check the other side of things here, and I plug in the negative version, well, what changes if I make it negative? Well, let's find out. Square root of 3, and then now it's a negative 2 square root of 3, because we had both options being squared. That equals 6. Well, if I distribute this 2, and I square something negative, what happens when I take a negative times a negative? Well, as we know, it's still going to be a positive. Just to write it like I did before, it still ends up being the same thing underneath the radical, so we know it's going to work this way before. We've seen this before. So now that's the square root of 36, which is in fact equal to 6. That was a historically bad 36, so I'll rewrite that. Is equal to 6. So both you have a positive and negative work out there. So we can check them there, but we can also notice because we're plugging a positive and negative directly back into a square here, it doesn't matter what the sign is. As long as one of them works out, they'll both actually work out just because of the situation though. I'm going to erase that just to give me some room moving forward. But you can always go back in the video to watch it, right? Alrighty. 7, square root of 2x plus 1 is equal to negative 2. The radical is isolated because everything's underneath the radical on that side. So we'll square both sides. 2x plus 1 is what we're left with on the left side. And then negative 2 being squared is positive 4. So now we subtract 1. 2x is equal to 3. And divide by 2. X is equal to 3 over 2. Now when we go and check here, like we have been, because we're good math students, plug it in. 2 times 3 over 2 plus 1 equals negative 2. Well, 2 times 3 halves, let's simplify. It's like a 2 over 1 if you think of it. Square root of 3 plus 1 equals negative 2. Square root of 4. Wait, does the square root of 4 equal negative 2? No, it equals positive 2. No real solution. Okay, or as we called it before, no solution. But I'm going to call it no real solution, just to be a little more specific. Because there's technically an imaginary solution to this, but there's no real solution. Okay, there's no real numbers here. And a little tip off here that we can know is actually the note we had earlier, where it said, a radical will be greater than or equal to 0 since we do not get a real number when we take the square root of a negative number. So when we have an entire radical equaling a negative number like we had here on number 7, that's going to be an issue for us. We're going to say, oh, there's actually no solution. Okay, we want to work out what the solution would have been, but we say, oh, that's actually an extraneous solution. It's an extra one that didn't actually work out. So that's just important to keep watch of there. Okay. Continuing on to number 8, square root of 2a plus 5 equals 3. Both are radicals, so let's square them both. Excuse me, the left side's all underneath the radical, so let's square both sides. Left with 2a plus 5 equals 3. Subtract 5. 2a is equal to negative 2. Divide by 2. and a is -1. Plug back in to make sure it works. And we can end up having 2 times -1 plus 5 underneath the radical equals 3. Well, 2 times -1 is -2. Square root of -2 plus 5 equals 3. Excuse me, I did that wrong. If anybody might have noticed my mistake already, I know I certainly did. Earlier, I said 3 squared was 3, but 3 squared is actually 9. So when you subtract 5 from it, we get 4. And so we end up getting a to be positive 2. Okay, I said it was positive or -1. We end up getting it to be positive 2. So that's going to change some things there. So I'm going to be plugging in a positive 2, giving us a 4 plus 5 over here where we're checking is equal to 3. So square root of 9 is equal to 3. And yes, it is. So sorry there, I noticed a mistake I had made there. Okay, got some more examples here. Got quite a few of them for us today. So I'm going to keep working through them. Number 9, square root of 3b plus 1 plus 2 equals 6. Now we can tell this plus 2 is not underneath the radical, so we need to isolate the radical still by subtracting it. Square root of 3b plus 1 equals 4. Now we can square both sides. Left with 3b plus 1 on the left and 16 on the right. Subtract 1. 3b equals 15. Divide by 3. And b is 5. Plug it back in like good math students to check it. And we get 3 times 5 plus 1 underneath the square root plus 2 equals 6. 3 times 5 is 15 plus 1 underneath the square root plus 2 equals 6. Square root of 16 plus 2 equals 6. And square root of 16 is 4. 4 plus 2, hey, that does, in fact, equal 6. It did work out. Okay. Let's look at number 10 here. 3 times the square root of 5x plus 9 equals 6. Divide both sides by 3 to get the radical by itself. Square root of 5x plus 9 equals 2. Square both sides. 5x plus 9 equals 4. Subtract 9. 5x equals -5. Divide by 5. And x is -1. Plug it back in to check it like good math students. 3 times the square root of 5 times -1 plus 9 equals 6. Well, working inside out. 5 times -1 is -5. I'm going to jump ahead and say -5 plus 9 is 4. If you need to put that in 2 different steps, you can. 3 times the square root of 4, 3 times 2. Does 3 times 2 equal 6? You betcha. All right. On 11, square root of x minus 5 is equal to the square root of 2x minus 4. Wait, this is something we have not seen before. Well, we have 2 radicals, but they're both isolated. So let's square both sides. On the left, x minus 5. On the right, 2x minus 4. Both times the square undoes the square root. Now we solve like normal. Subtract x. -5 is equal to x minus 4. Add 4. -1 is equal to x. We have to go back in and check it like good math students. -1 minus 5. Square root of -1 minus 5 equals the square root of 2 times -1 minus 4. There we go. -1 minus 5 is -6. 2 times -1 is -2 minus 4. Now we already noticed the left, that's a negative number. Well, that shouldn't happen. We should not have the square root of a negative number. But if we don't happen to notice that yet, we can keep going and say -2 minus 4. That's also -6. Well, yeah, it's true that the square root of -6 is equal to the square root of -6. But we don't want the square root of negative numbers. So we're still going to call that no real solution. Number 12 here, we have the same setup we had in 11 where both sides are radicals, but they're both isolated, so let's square them both. Now, real quick, actually back to number 11 here. The reason we call that no real solution is because we're square rooting negative numbers, which leaves us with imaginary numbers. On number 12 here, though, going back, square both sides, we're left with 2t minus 7 equals t plus 2. Subtract t, t minus 7 equals 2, add 7, t is equal to 9. Plug it back in to check because we're good math students. We'll end up having 2 times 9 minus 7, make the square root, equals, running out of room here, 9 plus 2. 2 times 9 is 18 minus 7. Square root of that is equal to the square root of 11. Well, what's 18 minus 7? 11. The square root of 11 is equal to the square root of 11. Yeah, I'd say so. And those are positive this time, so we're good to go. Just a few more examples here, and we are done with this section. 13. Square root of 2x plus 7 equals 1. Okay, need to isolate. Square root of 2x equals -6. Now we might already notice, guys, hey, we're setting this up to where square root's equal to a negative number. That's a hint for us that we're going to get a no real solution. We're going to get an extraneous solution. But let's keep going just in case. And figure out what that extraneous solution is. So we square both sides and get 2x is equal to positive 36. Because negative times negative is a positive. Divide by 2. And x is 18. Now let's just prove that that was an extraneous solution by plugging it in. Square root of 2 times 18 plus 7 equals. I need to write this lower because my it's grabbing part of my screen here. Square root of 2 times 18 plus 7 equals 1. 2 times 18 is 36. Square root of 36 plus 7 equals 1. Well, square root of 36 is 6. 6 plus 7? That doesn't equal 1. No real solution. Go on to number 14 here. We have to multiply by 3, or a 3 over 1 if you prefer, on both sides. Get square root of a is equal to 6. Square both sides, and a is 36. Double check. Square root of 36 over 3 equals 2. Well, square root of 36 is 6. 6 over 3. You betcha that equals 2. That one works out. Now I have a word problem here, so let's practice this word problem. With no air resistance, the time t in seconds that it takes an object to fall h feet can be determined by the equation t is equal to the square root of h over 4. If an object is dropped from the top of a building and reaches the ground in 2.5 seconds, what height was it dropped from? So, I like to underline information, so here's our equation, probably important. We know it's dropped from the top of a building and reaches the ground in 2.5 seconds. So that's going to be our t, our time. And we're trying to figure out what height was it dropped from. So we're trying to find h. We have t, we have h, we know t, and we're trying to find h. So we take the equation, t is equal to the square root of h over 4, and we plug in t. So we end up getting 2.5 is equal to the square root of h over 4, and we solve. So we solve the same way we've been solving the problems. We multiply both sides by 4, or 4 over 1 if you prefer. And 4 times 2.5 ends up being 10. Now, if you don't want to do this off to the side or you don't know it, you can say, okay, well, if I have $2.50, 2.5, $2.50, and I have 4 of that, well, then that's $10. Or say, oh, something costs $2.50 and I want to buy 4 of them, well, that'd be $10. So we have 10 is equal to the square root of h. We need to square both sides, almost said square both sides, undo the square root, and 100 equals h. So what was the height it was dropped from? It was dropped from 100 feet. And we can even make it like a little emoji if you wanted. And that is this section, guys. We are done. Nothing on the next slide. We are Gucci, good to go. So that finishes up actually all of chapter 9 over radicals.